So my brain's like, mostly here. And I'm in a wonderful mood. Isoquants. What do isoquants do? They capture the trade-off between input combinations, combo wombos. So this is almost always capital and labor, but it could be any input, okay? That yield the same output in the long run when all variables, all inputs are variable. Not all variables are input. I guess that would kind of be correct too, though. So part of our isoquant cost minimization equilibrium journey has to do with another like rate of substitution. I know, you're sick of it, right? There was our market rate of substitution. There was our marginal rate. Now we have a marginal rate of technical substitution. I know. I hated it too when I was in grad school. Should have just quit. So the marginal rate of technical substitution, this is the rate at which a producer can substitute between two inputs, maintaining the same level of output. And so this marginal rate of technical substitution, it is the absolute value of the slope of the isoquant. So our marginal rate of technical substitution between capital and labor is equal to our marginal product of labor and our marginal product of capital. This one does not go mnemonically. The K doesn't go on the top this time. That's really aggravating. Why? Stick with a convention. I'm not frustrated. You're frustrated. All right. Family of isoquants, figure 5-3. So we've got capital on our y-axis, we've got labor on our x-axis, and we've got a nice convex to the origin quantity 1, which is 100 units of output. This is all my capital input, and this is all my labor input. So if I'm here, pardon me, and I'm using this much capital and this much labor, which direction would I need to go to substitute labor for capital? To substitute labor, so I'm getting rid of capital and I'm substituting labor for, I know, I hate that expression. Substituting something for something, it always confused me too, honestly. So it would go down, yeah. So I'm replacing, that'd be a better way to phrase it, right? Replacing capital with labor, or substituting labor with capital. That's clear rather than substituting labor for capital. So we'll say that. We'll say substituting capital with labor, because then it's clear what you're getting rid of and what you're replacing, right? 4 is kind of like not the best. And so this is a family of isoquants, right? And so that was our hint that there's not just going to be one. There are different isoquants related to different units of output. And so as we go out, we are increasing the amount of output. And so within all of these graphs, we have a diminishing rate marginal rate of technical substitution. So when we go from someplace like A, so I need to finish labeling. Q0 equals 100. So we go from someplace like A. Let's say we were doing the example where we're making autos, right? And we've got so many robots and so many laborers, right? So let's say that we, because of the increase in the wages or whatever, right, for whatever reason, we'll get to that, we end up decreasing the number of laborers by 1. Well, when we change it by 1 here, we're going to have a pretty corresponding one-for-one kind of exchange, right? We get rid of 1 labor, and we're going to increase our capital by 1. But this is really an artifact. So the slope at this point is my rise over run, right? My change in my capital over my change in my L, so it ends up being -1 over 1, which is -1, and we know that the slope of these curves, right, this is our negative of our marginal rate of technical substitution between capital and labor. So what does that mean? That means that our marginal rate of technical substitution of capital labor at this point is just equal to 1, which makes sense. We're giving up 1, we get 1, right? Give me a second to copy that down. Now what happens when we're at a point like C? Sorry, these were labeled as well. A, B, C. So what happens when we're at a point like C? We don't have a lot of laborers, right? And we got a ton of capital that we're employing. So when we decrease the same amount of laborers for C, right? I actually need to extend this a little bit, because this same amount here now I'm going to have a change in my capital stock that's going to be equal to 3. So essentially, both labor and different types of capital and different types of inputs, they're better suited to certain production processes than they are to others, right? Somebody might be better off on a farm compared to on a production line assembly compared to in a classroom. And so when we start to really force kind of an overextension in our use of either one of the things, we end up getting diminishing rates of substitution. So the closer and closer we get to a kind of all capital scenario, the more capital we're giving up anytime we are, or sorry, the more capital we're getting anytime we are giving up a laborer. And the more that we get over here, it's a similar thing, where our trade-offs end up deviating from this one-to-one. And so our slope here so that means that our marginal rate of technical substitution is 3. So it starts out as 3, goes down to 1, and if we wanted to, we would find that going from A to some point like E, right? Let's say that we wanted to decrease capital by 1. What would we get in terms of the increase in the labor? We would get an increase in labor of 3. And so what would our slope be here? It'd be negative 1/3. So our marginal rate of technical substitution, the absolute value of that slope, is going to be equal to 1/3. So we can see this declining marginal rate of technical substitution, right? It's 3 here, and then it's 1 here, and then it's 1/3 here.